everybody. It's the T2sday update. Welcome to 2026. I've got a little clip I'm calling The Surge to show where we're heading this time. There it is. And now we're hitting the surge. I mean, this is running on the quiet box. I am displaying it here on my local workstation. And not only that, I am also generating a live stream over here. And there comes the surge. So there it is. I've got a ton of stuff to talk about. Ending up, I want to get to a demo of a live demo of that surge that we just saw. So I'm gonna try to go really fast. The title is a little bit weird. It should make more sense going along, but it's got to do with machines that you could rely on because they're robust. You know, if they can figure out a way to do it, they will do it. All right, let's just jump into it. So the goals for today. January 6th, clean up code base, graphical, here's how we did. Clean up the code base, well, yes and no. I did clean it up significantly. On the other hand, I created a whole lot of new mess. Graphical output, well, you know, you saw, so there's text-based graphical output. That's, you know, very 70s, but it's good because it's easy for me to do development work on it. All I need is a terminal and I can watch and see what it's doing. I don't have to connect with a real full pixel level environment. Physics language dreams, that's going to have to wait for another day. Write English, damn it. I did a little. I did not do nearly as much as I was supposed to, and I was hoping I would, but I did do some, and possibly I've turned the corner on a shape for the whole thing that will let me squeeze it out. We'll find out. So today mostly I want to go through the timeline doing the work and then show the surge. And there's not going to be time to talk about the robust dreams. We're going to push that off till next month. 63 days ago presented the previous T2sday update 3167. The way it worked, it had the thing working, and it was printing log files in the background. It was printing out text versions of the grid, and I had a Perl script that was digging through the log files, clearing the screen and describing the next one. So wanted to go far beyond that, and I started to work on, I don't know why collected works ended up being called cow with a little o, but that's what it stands for, collected works. The collected works of the Living Computation Foundation is the name of the thing that we're working on. At T-minus 61 days, you know, I mentioned a couple of months ago that I had a kind of good experience, you know, with getting an AI coding to help me with what was for me a complex CMake setup and so forth. I tried it again. It was an utter failure. It was lying off its ass and going in circles. And every single time it was like, for sure, this is right. This is absolutely for sure, and so forth. On Friday, I overslept a meeting. I hate that. That's so terrible because I'm kind of a jerk about people trying to actually make meetings if they show up, and then I blow it. It's terrible. But by Saturday, Textual is this Python package that does terminal-based graphics. I'll talk about that more in a bit. By T-minus 55 days, I was starting to see the trouble with Python in particular. Somehow I was generating a tremendous amount of garbage, which was causing garbage collection delays, which were being pretty ugly. But I set a new goal that, you know, last time I talked about the event window acceptance ratio, because I was sending out, I was picking random events based on what the center saw in the grid and sending them out to T6tile to do it and then collecting the results back up. And there was no defense against two tiles both getting the same event, and then one of them got there and it wouldn't apply because someone else already got it or did a different thing. So the goal was to say, let's come up with an algorithm that will allow us to put a lock on an event window, a region of the overall grid, but let's make sure it's reasonably robust and can't get screwed up and so forth. So I ended up with this thing I called space-time volume locking, STVL, which is really an old algorithm. It's sort of like a nearest neighbor kind of thing where you have buckets and you search the neighboring buckets and so forth. The only difference is that instead of having to unlock it, the space-time volume lock, you only get it for a period of time. You get this much space for this this many milliseconds. And if you haven't checked back in by then, the next person can go ahead and bust that lock and keep going. And so we're back to where we were before, where it's possible that not all event windows would apply, but most of them will, and it all goes much better. On T-minus 51, Dave has hardware problems. Without going into it too much, it's all very sad and disgusting. But you know, I was bleeding a lot. Not supposed to be bleeding a lot. I ended up spending 2 nights in the urgent care ER and 2 more nights in the hospital. And you know, it was a drag. So you know, here I was in the emergency room. You know, I'm wearing my own mask here. Like, you know, I've been trying to stay away from people for 5 years, and over the week of this period, I had got more people in my face than I had in the previous 5 years. And this, you know, all right, and I was there for a day, and then after 2 days, I was transferred to a regular hospital in an ambulance. And, you know, I had never been in an ambulance. I'd never been in a gurney and being wheeled around and all this stuff. I mean, I could have walked, but it was, you know, supposed to do it for care, to be careful and so forth. And the whole thing was surreal. It looked just like a medical show. And there I was being the medical patient. I'd never been a patient in a hospital before. This is a first for me. You know, here I am in the elevator on my gurney. This was kind of nice, you know, since the ambulance people have to wear gloves and they have to change gloves for every patient, then they can do smart things like write the room number on the glove so that you have the information you need at hand. I was impressed with that. And here I am in the hospital room. And 2 days later, I was thrilled to see the ride home. And really, so, you know, I'm okay now. I have to go get a few more tests, but my overall feeling about this, you know, because really, you know, I was bleeding, and then I gradually stopped bleeding. The bleeding abated, and my feeling when I got home was, wow, you know, it's good to be alive, you know, and thank you, Dave. Thank you. Well, thank you, Dave's body. Good machine. And I think that's, you know, it was a worthy echo for me of the incredible robustness and healing. You know, even if we can't regrow our tails like a lizard, we do pretty damn well. And so this was a nice little reminder. And then it was right back to the hack. Textual, the curses, the Python curses thing, it's really a mixed bag. You know, it's got all kinds of super features and this kind of decoration, that kind of, for beauty, but when you really want to pound it, if you really want to go fast, like have a lot of display happening, it's a little bit slow. And, you know, to eventually get a grid, just like we saw in the opening clip that we'll see a demo in a couple of minutes, to get that working took like 4 days, and I had to go through several different ways. I started out trying to use the all singing, all dancing textual approach, and ended up having C++ code just pre-generate the entire frame as a single string and send a view of that string off to Python for speed. I set another goal. I said, okay, I've got this crappy little text-based graphics, and we'll get pixel graphics and pretty stuff eventually as well. But this was important for development purposes, and I want to be able to live stream the simulation to the world. So having the ability to display on a single terminal was great for development, but not great for, you know, showing people what's going on. So I started into that, and I did some searches, and your Nginx and the RTEP module is sort of the open source way of doing these things, it turned out. And so I went to work on that. And at the same time, I was daydreaming. I spend a lot of time daydreaming, and I've decided I should talk about that because it's an important part of my work process. It comes before setting goals. So at first, there is this process of ring oscillators that I used in the T2 tile stuff in the Ulam code in a number of places. I did a video on the Dave Ackley channel, Robust Local Synchronization, that talks about ring oscillators. I'll link to it there. And I was thinking about I could use it here to coordinate if I'm moving from, instead of having the x86 box in the center coordinate all the event windows getting thrown out and pulled back, that we want to delegate that back again toward the tiles, so that they're taking care of little patches of space, and they have to arrange with each other when they want to do something that involves somebody else's patch of space. So I thought about using a ring oscillator around the corners of the tiles to allow them to coordinate, because a ring oscillator very naturally produces a single winner. Yeah, I mean, it can have a few subtle cases, but that's basically what it was. However many days later this was, I'm not sure. I ditched Nginx and rtemp. Oh man, that was many miles of bad road, and I did not enjoy it at all. And I think the answer is that Nginx went commercial a few years ago, and so now they've stopped supporting the open source rtemp module, and you're supposed to get the paid one. Well, we're not going to play that kind of game. I found Media Matrix, Media MTX. It was great. It was super easy. After having wasted so much time with Nginx and rtemp, I was able to live stream hours of the sim. I mean, just in my little internal network. And as we saw, it was displayed in the Surge video. 27 days out, for some reason I got this idea that I wanted to count events, see how fast it was going. It's really the wrong time. It's way too early to be saying, is this running fast? I mean, because it's doing the centralized stuff. It's not even using all of the black hole cards that are in the quiet hole box. The quiet hole. The black hole quiet box. Nice. And it's not even running the cards at max speed. So there's tons of things, but I couldn't resist. And I had been trying to simulate a grid, a cellular automata grid of 4K size, 3840 by 2160 sites, because that would be pretty damn cool if you could have a simulation where every pixel of a 4K thing was a live atom doing some individual thing. And long story short, when I tried to use the code that I have now, I achieved, this is a I wouldn't really call it an achievement. 24 milliair. 1 air is 1 event per site per second. A milliair is 1,000th of an event per site per second, or 1,000 seconds per event per site. And so I got 24 milliair, which is about, I still think actually it may be faster than the T2 tiles, although the grid size is not exactly the same. But this was way too slow, given that the goal of the stuff was to go faster, and so fast enough that we could see things moving. So I ditched 4K, I went down to HD, and that's what I'm going to be dealing with for the foreseeable duration now. A grid that's going to produce a 1920 by 1080 grid of cellular automata sites, so we'll see what happens. And so far, using the terrible everything, I'm getting 115 milliair measured on HD grid. 26 days out, the dream of using ring oscillators for the camera became a goal. That's the video on the Dave Ackley channel. I started working on it, and it turned out that, well, in order to do that, I have to be able to send packets from one T6 tile to a neighboring T6 tile, which I hadn't done ever. All I had done was send packets from a T6 tile to the host, and from the host back to an individual T6 tile. You wouldn't think it was going to be that different. Well, it turned out to be, both because of just because it was different, and it was a little bit complicated, and because I got a little thrown off by the documentation. Documentation a little bit misleading. It took over a week to get it all sorted out. But 15 days ago, the T6 tile corner rings finally started ringing. They were synchronizing, and they knew what was going on, so that was great. That made me happy. And 2 weeks ago, I started thinking, okay, well, we've got this signal going around the ring. So each guy takes a turn thinking southeast is active, and when he's done, southwest becomes active on the next tile over, and then he passes it down. So northwest becomes active on the guy below, and then northeast becomes active on the last guy in the square, and then it goes back up to southeast, and it goes around and around. And it just sends a single 32-bit word, which is enough to coordinate what they're doing. But now I wanted to actually send event windows around and collect up sites that other things owned and then distribute the results back to them and so on. I also found this is another huge nerd thing. I was doing a terrible thing. I was doing something that I knew was bad. I was using a union, and I was using it in an unsafe way, and I got screwed. But, eventually I found it. Okay, great. 11 days ago, set it as a goal to get event windows going around the corner. I still have a question about exactly how data delivery works on T6 to T6 packet deliveries. You sort of might have assumed that when you send a packet, suppose it's supposed to go from address 1000 to address 2000, you might sort of imagine that as the data arrives, it'll hit address 1000 and then work its way up, and then it'll end by hitting address 2000 or whatever it is. That turns out in the previous generation of hardware to not quite be true. And so I asked, but the documentation about black hole, how it behaves, is not there. And so I've asked on the Discord, and I'm going to have to re-ping because I kind of want the answer to that. 9 days ago, I cleaned up the code, and, this is one of these things where I had two variables, two data members. It doesn't matter what they are, really, but one was called mLastState, and the other one was called mNewState, and you're supposed to change those in all kinds of synchronized ways as the behavior changes going around the ring, as you got the guy who's in charge, the guys who aren't in charge, and so on and so forth. And I couldn't get it where I kept having millions of mistakes, and I made one change. I got rid of mLastState and mNewState, and I called it mLastReceived and mLastSent. And that just made everything so much clearer because those were the visible events. Those were the things that happened, when received from a different T6 tile, sent on downstream in the ring. Then the code cleaned itself up almost. That's the way it felt. And I got event windows going around the ring following the token. 6 days ago, it's taking way too long, so I'm going to skip this. Talk about regional hubs next time. 4 days ago, cleaned up the code again. I was actually working on collected words. You notice I did an awful lot of hacking. I was going to say, it was in the middle of November. I was going to do all the writing, and then I had to go to the hospital. Yeah, that's my excuse. So I finally did do some work on it, and I made some progress, but it's still... And yesterday I assembled the timeline, I figured all this out. I decided that I actually did some genuine work, and I made the slides, and here we are. So, okay, let's do a demo before we run out of time. All right, can we see this? Oh, let's pretend we can. All right, so I've got this paused, and I'll start it up again here. That's not what I wanted. I wanted to do that. All right. So this is Fork Bomb, and it looks like it's just tiny, like a 10 by 10 Fork Bomb grid, but it's not, because we are zoomed out here at the moment, and if we zoom in, this is what it really looks like. That's the current state of the thing. But we'd like to get it all on screen. So we can zoom out like this, which makes it look smaller, but actually all those sites are in there. And, it's not doing much of anything. But if we watch in just a minute or two, or a few seconds really, it should, let's zoom out a little more. All right. So there it goes. So that's the surge. And what's happening is all the space-time volume locking algorithm early on is tying up all the atoms, saying, oh, this one's busy, someone's got an event, and lots of the T6 tiles don't find any work to do, and yeah, I've got some problems where they end up stepping on each other. I'm not completely sure about it, but once the grid gets populated enough that there's plenty of events to do, then it starts to fly, and that's pretty nice. And you know, so we can all right, so there. So now that's the entire grid. This is an HD size with a a cross hatching of nothing around it. We can hit it with some nuclear bombs, and it does what Fork Bomb does. It recovers. So that is currently state of the art. This is the textual app. I'm not going to show the live stream of it because it's taken too much time. But there it is. And so the goals for February 3rd is to get those T6 rings that are now circulating event windows so that they can do intertile events in this different way, get them somehow displaying. I mean, right now the problem is all at the moment, all of the grid is in the center. So displaying the grid in a global fashion is easy. But once we distribute that all out to the tiles, we're going to have to somehow re-centralize the results of the grid so that we can display it. Consider regional hubs. We'll talk about that next time. Live stream Sim to the world. Maybe, I'll announce it on the Discord a couple times, and hopefully somebody will be willing to take a look and see how many people we can actually see before my pitiful internet connection falls over, and continue to try to find some fun in this POS world that we're living in. My God, I really feel the need to say, if you are not a citizen of the United States of America, I'm sorry. I apologize to you. My country is, oh God, it's so on that sad note, but still have friends, still have life going on. Life goes on. Good machine, Dave. Good machine. I hope to see you next month. Alrighty, that's that. Not even as long as sometimes. Is this going to work? Oh, all right. Don't get learning new languages help you from getting rusty. Yes, that's right. 100% ARM 64 stacks of Beagle Play. I don't know what a Beagle Play is. The T2 tiles, these guys are based on the Beagle board Green way back when, which is like ARM 7, 32, and so on and so forth. So I don't know exactly. What's a Beagle Play? Is it cool? Tried to vibe code, yeah, so it didn't work that well for you either. Half of all doctors finished in the bottom of the class. Well, depending on the distribution, it could have been 99% finished in the below the average if one guy was, unbelievable. So the support was only temporary. Okay, that's got to be a terrible, terrible pun about RTemp, about the video stuff. I don't know. Hey, Parameterized, thanks for coming. My token ring flight plan, there you go, has previous, current, request, and acknowledged states. Yeah, I mean, the problem I had, previous and current, in my mind, saying last state and new state were meant to be something like that. The problem was, in particular, the handling of new state. Like when in the procedural code that is running in the state machine I mean, if it was all table driven, that was one thing. That would be one thing. But I didn't understand what I was doing well enough to to be able to boil it down to a table in any satisfying way. So it was procedural code, and saying, you know, okay, am I at the new state yet, and so forth. I'm old. Well, I can do this stuff, but man, it takes me a long time. I have to make every single possible bug first, it feels like, before I'll finally do it right. And last received and last sent ended up being what did the trick for me. Now, there's other details, because once you've got the token, once you're holding the token, you actually need to do some like sub phases within being the active guy, and you need to signal to the other ones around the ring which sub phase we're in. Like, I'm sending around an event window, and if you own any sites in this window, populate it and then send it on to the next guy. So when it comes around the ring, we've collected up all the sites we need, then we can do the event, and then we can send it around the ring again and distribute the results back. Is that the best way to do it? Who knows? I'm not worried about that. One of the things that is true about these black hole things is that, again, compared to, you know, my lovely T2 tiles, the inter-tile communication is so slow that the NOC, the network on chip of the black hole, is like, it's a monster. It's just whoosh. So I'm trying things like, just, you know, what the hell? No, don't have any cache at all. Don't have any cache of other sites. Just ask them. When you need to know it, send a packet around, collect the latest information from the owner, do an event, and then send it back. And since the ones who are filling in that information know that a different tile is the one that's being active, because that's what the token ring is controlling, they won't go ahead and make other changes to those things that are needed by the thing up front, and so on, and so on. So we'll see. So I have to make a few little sub-phases within active versus inactive to specify, collect data, do the transition, distribute the data, and then pass the token like that. And again, I imagine, TCB Quick, that I hope your code is cleaner than mine. I bet it is. Again, it's better than my code's cleaner than it used to be, but still. Anyway, so yeah, so the I'll give you a little taste of this regional hub business before we end up here. We'll try to wrap up at the bottom of the hour. Brock and I got a few things working. Syntax error, yeah. And at first, the apologies and saying, "Oh, you must be really angry at that," you know, it was a little bit endearing. But then after a while, when it was, for example, starting to loop and make the same recommendation it had previously made that did not work, that's when the self-deprecating statements didn't really satisfy very well. Anyway, so here's the thing. In the T2 tiles, you know, each one of these has a little patch of sites, of grid sites, each of which contains the atom, and it's got neighbors, they have a bit more, and so on and so forth. Getting an event to happen on this thing, you know, this tile owns these sites. You know, the ones that are on the edges, the inter-tile ones, they have special caching and locking and all kinds of stuff that, if you've been a long-time follower of the T2 tile project, you've heard plenty about inter-tile locking. But for example, the sites that are right in the middle, the only processor in an entire T2 matrix that will ever do events in the middle of this grid spot is this tile itself. There's a one-to-one relationship between spatially distributed sites and tiles, and that makes perfect sense. That's why I did it. But it does have this one problem, which is, you know, if a tile goes out, if a tile goes bad, you know, there's those sites that are in the middle of that tile, no one can cover for them. No one knows what's in there. The way it's all set up, this is the only entity that can run events for those guys in the middle. And, to me, that just seemed like sense. That just seemed like the obvious thing to do. But once I started doing this new thing on the Quiet Box, where I was selecting events miles away, different architecture on an x86, and then just collecting the event window and sending out, here's the before event window, please fill in the corresponding after event window and send them both back to me. And then I go and recheck where that was supposed to go. I kept track of its position on the grid, and I check and make sure that the previous still looks like the previous, and if it does, then I apply what it's supposed to look like, and so forth. That eventually started sinking into me that, there's no actual reason why the individual sites have to be only handleable by the tile that's sort of closest to them in the center. So what if, for example, you took a 3x3 grid of tiles, not T2 tiles, but maybe T6 tiles, 10-6 tiles. And so now you've got 9 tiles here, and the one in the center, you call that the hub. You call that a regional hub. And it starts out being responsible not just for the sites that are in its tile, but for the sites in the 8 tiles also around it. And it farms out, it collects event windows, farms them out, collects them back, and distributes them, just like the T6 ring oscillators are going to do. Well, they actually are doing that at the corner level. And what that means is, well, geez, suppose one of those tiles goes out. Well, that's okay, because as long as we've still got a hub guy there, he can just not send events to that one. We can cover that space by having other tiles nearby do the events for them itself. And then, if eventually this tile gets replaced or it gets fixed or rebooted, whatever it is, and it starts picking up its slack, then it starts doing events, we can hand it back to it. And from there, we can go on to say, well, what about moving the regional hub around? It doesn't have to be fixed in a location. So the idea is, let's do that. So it's not centralized in the sense that the entire grid goes to one place, but it's not completely microscopically decentralized either. It's in between. There are little regions, and within the region, the individual tiles can cover for each other. And if one of them goes out, or a few of them, whatever it happens to be, well, it's just that region of space will go slower, because there's fewer processors around to do events for it. But the whole movable feast machine is supposed to be robust to varying event rates. So that's the idea. And I actually talked about this possibility in a paper in the A-Life journal long ago. I explicitly made room for the idea that there could be a violation of the sort of spatial map down at the bottom, but eventually space has to dominate. These regional hubs need to be reasonably close to their workers, or else we're going to get completely buried by network traffic. Even if we have a network grid that's willing to route them all over the place, we're going to blow out the bandwidth immediately. So this idea of having a regional hub does not keep scaling up. The regional hubs are going to have to coordinate with each other now to say, well, we all came up with this set of changes, and this region is active now, so I'm going to tell you what's happening in the boundary between us, and then I'll pass the token to you, and so on. So that's what I would really like to get working, and that may take half the year. I don't know. We'll see. I am going slow. Getting a little old, I admit it. But still plugging along, still having fun, still finding good ideas. And I went blabbing past. All right, so let's just check back. Started to feel bad for Grok. Yeah. I didn't. I kind of sort of did too. I mean, it was Gemini, whatever, but it's the same thing. Isn't Grok the Twitter one? Don't we want to not be using that stuff? I mean, isn't gonna make, start when you give it a bug to fix and it'll show you porn or something like that? I don't know. I haven't tried Grok. Wasn't using model optimizer coding. Yeah. Using Beagle bones of every color. Okay. Beagle Play has, really? So are you still on Twitter, Punmaster? I mean, I don't make much of a secret of my politics, but I try not to lean on it too hard, just beyond. Beagle Play has RTC. RTC normally means real-time clock to me, for real-time OS. I don't know what RTC for RT. I mean, real-time OS. Okay. Yeah, okay. I believe you. All right. Well, hey, TCB Quick Punmaster parameterized. Schlabbermonf was here too. A couple of folks. Yeah, Schlabbermonf. And hey, it looks like we peaked out at like almost double digits in the live stream. So anyway, Happy New Year, and thanks so much for coming. And I'll see you on the Discord if you come around there, and otherwise. I hope to see you all next month. Okay. All right. Let's stop streaming. How do I do that? I guess I go here. Yes, I do. Okay.